Good evening. So, this is the day 4 of our physics daily practice program. So, we have completed, alhamdulillah, we have completed 3 MCQs, right? So, this is the fourth MCQ in our row, right? So, this is the fourth question in our daily physics practice program, right? So, so these days I'm just focusing the mechanics, MCQs. So, in order to just to um to revise the content to these MCQs, right? So today's question is not from a model paper or a provincial or a model 2 paper. This was an actual past paper question, which is 2020 A level paper, and it is the question number 22, right? So this is not a new type of structure for the A level students. They have come across these type of structures. This is a pulley system, right? So first of all, let's read it and let's apply our set of rules how we can apply. Normally we are how are we doing these questions? Now we have done almost 3 questions for the past 3 days. So this is our fourth question. The same concept. How? First we should read the question carefully. Second, we should analyze the question and arrange the information in an orderly manner. And third, we should identify whether what are the laws we can apply, what are the equations we can apply, and what are the content which we can relate here, right? Okay, first of all, let's read the question, right? Two blocks A and B of mass zero point 0.5 kilos, mass is zero point 0.5 kilos and 1 kilos respectively, are connected by a massless inextensible string which goes over a massless smooth pulley. Smooth pulley means there is no friction involved here, right? As shown in the figure. The coefficient of dynamic friction between all the contact surfaces is 0.25. What is the force F needed to drag the block B to the left with a constant speed R? So constant speed means you should know acceleration equals zero. Constant speed means acceleration equals zero. Why? Because constant speed means there shouldn't be an increase in speed. Acceleration means the rate of change of velocity. So if they have mentioned something called constant speed, there is no acceleration, right? Okay. So if there isn't an acceleration, what can we come? What is the conclusion we can come? If there is no acceleration, we can say that if acceleration equals zero, we can say that the resultant force would be zero. Ah, this means the system would be balanced, which means there is no resultant force. If this force is an external force which we supply, this would be balanced by something a force in the opposite direction. That is the idea, right? Now let's see, this is the pulley system. So what are the concepts, right? Now if you are a bit familiar, no, as soon as you see the question, if you can do, just do it. For the new ones who are not yet started the practice of papers, just see first, we'll see what are the concepts we can apply here. First one, this is about a pulley system, which means we should know how to mark forces first. Marking marking forces gains almost one of fourth of the question would be right if we mark the forces correctly, right? Second one, we can see that there are forces here, so we should know the knowledge of forces here, right? So when it comes to the knowledge of forces, there are mainly three laws which we know. Even the older students know that Newton's laws, right? Newton's laws, right? Newton's laws, there are three main laws with respect to this linear motion, the motion which we study under mechanics. So Newton's first law, second law, and third law. Right? Okay. Now let's go into the working part. How we can apply. So first of all, what shall I do? I'll just mark here in the diagram itself. Right? Yeah, rather than using in the diagram, I draw it separately and mark it, right? It'll be easy for the students to understand, right? So the diagram looks like something like this. There is a small weight, right? And there is a large weight on the bottom, and there is a inextensible string, and there is the smooth pulley they have mentioned. So it is going like this and it is coming like this, right? So there is a surface in this ground, and I'll mark it like this. Okay, right. So they have said the top mass as A and the bottom mass as B, right? So rather, it's, I guess they have, as they have mentioned, no need to mention it again, right? Okay. So what can I do? Let's start marking the forces. Okay, right. If you see there's a string, if there is a string and there's a mass, confirm there would be a tension created. There would be a tension created. So here in this direction there's a tension, in this direction there's a tension, right? And here there's a tension, here there's a tension, right? Okay. If you see here, here there would be a reaction force. I'll take this as RB, right? There would be reaction force that is exerted by the weight on the flow, right? So similarly, here also there would be a reaction force which is Ra, and there would be a reaction force that is exerted here, Ra, on the bottom weight also, right? Fine. So they have said that we are externally supplying a force, it seems, which is F. Okay, so this is also a force. F is supplied. So just think, if there's a mass on top and the B is like this, right? So they are saying the B, they are, right. If this is the mass, right? They are pulling the force, the bottom force in this direction, right? In this direction, it will be going on this direction. So can you understand? There would be frictional forces acting. Why? Because they have said that they have introduced us the coefficient of dynamic friction, which means they are indirectly saying all surfaces have friction in it, right? All contact surfaces, which means all the surfaces which are in contact, there would be a friction created. Let's see what are the surfaces that are contact, right? I'll mark the frictional forces in green color, right? If you see this, now I have keep, I have mentioned a gap here. Actually, they'll be in surface touch, right? They'll be in contact. I have mentioned a space, yeah. I have kept a space just to mark the forces, right? Okay. Now, if you see, I am pulling. Just think this is a pulley, and I'm pulling this in this direction. What happens to this mass? This mass will be eventually going in this direction. So this mass is going in this direction. Frictional forces, what they do? They will be opposing the motion, which means if the mass is moving in the right direction, frictional force would be acting in the left direction, which means there would be a frictional force that is exerted on the mass by this surface in this direction. I'll mark as frictional force 1, right? So if this, no, if this surface is creating a frictional force on this direction, this mass will create another frictional force in this direction. Why? We know it from Newton's third law. Every action has an equal and opposite reaction, which means if there is a force in this direction exerting, this will be exerted in this direction just to cancel it off, right? So there would be a frictional force created by this mass or by this weight on this surface, right? Just think the normal vehicle which we use to go in the road, right? The tire pushes the flow backward, the flow pushes the tire forward, right? Similar, so similar idea can be applied here also, right? So if I do it for this structure, right, this mass, I'll do it for the bottom mass, which is the B, right? So here the weight is being pulled on the left side direction, right? So what, in which direction will be the friction taking place? The opposite of it, which means in this direction. So here the flow will be pushing the mass B on this direction, which is friction 2, right? And the mass will be pushing the flow on this direction, which is friction 2, right? Okay, I guess these are the forces up to now. Let's see if there are any forces that are involved. I hope these are the forces, right? Now we have completed 1/4 of the question, which is marking the forces. Now let's go into the working, how we can work these questions, right? Okay, right. Now I'll apply F equals ma equation for the mass number one, which is A, right? The top one. So that is moved in what, which direction? It is moved in this direction, which means on to the right side. So I'll mark it in this direction. Force, let's see what is the force. So in this direction, right direction, which is the force, tension is acting T, right? And friction is acting in the opposite direction, which means minus FR1, right? Minus FR1, and mass is point. I'll mark the mass also. Mass is 0.5, right? Acceleration. What about acceleration? I mentioned it in the question. Acceleration is equal to 0, right? Acceleration is equal to 0. Right? Acceleration is equal to 0. Right? Okay. So if mass 0.5 into 0, so it will be eventually 0. So I can say that T minus Fr1 equals 0, right? So I can take this Fr1, which is the frictional force, onto this side. So I can say that tension equals frictional force 1, right? Let's find the frictional force. Mu K into R. Frictional force means coefficient of dynamic friction into the reaction force. So mu K, they have said that 0.25. Reaction force, let's see the reaction force. They have said the mass of A is zero point 0.5, which means its weight is mg. 0.5 into 10, 5 Newton. So its reaction force would be 5 Newton, right? So 0.25 into 5 would be 1.25 Newton. So these tension forces, the red one tension forces, are equal to 1.25. Okay, we have found the tension. Now let's apply F equals ma equation for the B mass, right? So F equals ma onto the B, right? Onto the B mass. And here this, it will be moving in this direction, which is onto the left side. The mass B would be moving onto this direction, right? So let's see what are the forces that are acting on mass B. The force F is acting, which is the one which we should find through this question. F, right? And let's see what are other forces. If you see this mass, all other forces act on opposite direction. This Fr1 acts on this direction, which is on the right direction. Tension acts on the right direction, and the Fr2 frictional force acts on the right hand direction, right? So I can write F minus, right? F minus tension plus frictional force 1 plus frictional force 2 equals to mass. What is the mass? Mass would be, here they have said it is 1 kilo in the question. See here, they have mentioned it as 1 kilo. So it is not the only mass. It will, the mass of the top weight also would be included, which means 0.5 plus 1, 1.5, right? 1.5 kilograms, 1.5. What is acceleration? As they have mentioned, it will be moving in a constant velocity. Acceleration would be 0. So similarly, as I did here, I can take this complete minus uh, vectors onto this direction. So it will be like F equals T plus Fr1 plus Fr2, right? I know T. What is T? T equals 1.25. I know Fr1 because T equals Fr1 here. So it will be also 1.25. Okay, 1.25. What I should find is Fr2. Fr2, right? I'll find Fr2 here. Right, I'll find the Fr2 here. Frictional force Fr2 equals mu K into the reactional force on B. Mu K is as usual 0.25, as they have mentioned in the question, right? RB, let's see the force that is exerted on the RB due to the weight that is created, right? So if you see 0.5 kilo from the top, which means 5 Newton from the top mass, and here it will be 10 Newton. So totally 15 Newton, right? From the top mass it would be 5 Newton because its weight is 5 Newton, right? Plus the bottom mass is 10 Newton. It will be 1 kilo. So if I mass convert into weights, it will be 10 Newton. So total it will be 15 Newton. So 0.25 into 15 Newton. 0.25 into 15 means 3.75 Newton. I have found Fr2. So I can add here 3.75 Newton. So F equals to 1.25 into 1.25 is 2.5. 2.5 into 3, 2.5 plus 3.75 is 6.25 Newton. I have found the force F, which is 6.25 Newton. Let's see whether we have an answer like that. Right, yeah, we have, right? The fourth answer, right? Right, the fourth answer, right? Can you understand how we, got the answer? Simple. We should have the knowledge of marking forces, right? And we should know how to use the equation F equals ma, right? Right. So that's the working for this question. Simple, right? So I hope you got something new, from this question, right? And don't forget this theory, right? I have done it, revised the theory part through a question, right? So that's it for the day. So let's meet in the next questions discussion, which means the fifth question, right? Thank you.